Okay, so today we're going to talk about percent error, and this will pretty much finish out our last part of our lesson. So if you could please make sure that you have your fill in the blank or student notes open and fill these in, and you will submit these notes in Google Classroom after you are finished taking the notes. So first off, this is your percent error problem. You're going to take your measured value minus your accepted value, enter in your calculator, divided by your accepted value, enter, times 100. It's really important that you break those down. Otherwise, you'll have to remember all of your parentheses, and again, you could end up with the incorrect answer. Your answer or your percent can be a positive or a negative value. This number is going to tell you how well you performed your lab. If you have a large percent error, then you mismeasured something, or maybe you forgot to take a measurement along the way. If you have a small percent value, that means that you perform the lab and the techniques very well. We'll be using that more with quantitative analysis as we move more into the chemistry units. So percent error, our formula is not always going to be set up with accepted or measured. So you're going to want to look for other key terms to help you out with that. So other key terms for accepted value could be known, true, standard, book, or I could give you a name of your text, a book or a textbook, or some sort of actual book, or actual. Those are different terms that would help with accepted. Other key terms that you're going to look for measured would be experimental, your measurements, your results, your data, or I could have somebody's name in there, such as Bob's measurements, results, or data. So let's go on and start the independent practice. So our first practice problem, we have Lucy estimated the mass to be 250 grams. However, after careful measurement, the actual mass was determined to be 240 grams. What is the percent error? Okay, so first off, we're going to pick out what is the measured value. So in this case, this is Lucy's because she's the one that did the measurement. Okay, so we're going to take 250 minus your accepted value. So, what is our accepted value? Another key term for accepted is actual. We said the actual mass was 240. And notice I'm not worried about putting grams in because they cancel out. So let's just focus on plugging in the numbers into the formula. And we're going to divide by the accepted value, which is 240. And we're going to take it times 100. So get your calculators out. Make sure it's not set in scientific notation. So you're going to enter 250 minus 240. Enter. So you should have 10. Divided by 240. Enter. Now you're going to have 0.041666667 times 100. And your answer is now in a percent form. I didn't press percent or anything like that. So my percent error is going to be 4.1, and I have 6666667. So let's just round that up to 4.17%. So let's say we have 2 decimals for our answer. And we're going to go on and circle that. So here, your label is percent. So please make sure that you label your percent. Please make sure I can tell that there's a decimal point there, and then circle your final answer. Okay, our next practice problem, we have Paul measured the length, width, and height of a cube, and they were 3.1 centimeters by 3 centimeters by 2.9 centimeters. The known volume of the cube is 27 centimeters cubed. What is the percent error in Paul's measurement? Well, before we can actually plug in and solve this particular problem, we have to calculate our value. So remember, since we're working with a regular shaped object, such as a cube, to find our volume, we have to take length times width times height. So we have 3.1 centimeters times 3 centimeters times 2.9 centimeters. So when we calculate that, we end up with 26.97 centimeters cubed. At this point, we're now ready to go on and use our percent error problem to calculate the percent error in Paul's measurements. So we know that Paul did the measuring, so that would be our measured value in our formula. So we're going to put 26.97 minus the known volume, which is your accepted value, which is 27, divided by 27, the accepted or known value, times 100. So we'll get our calculator out. 26.97 minus 27. Enter. Divided by 27. Enter. Times 100. Enter. And we will get our percent. This time we're going to get a negative percent. So we have a negative 0. And it's full of 1, so we'll just round up. Negative 0.11%. Okay. So when we're talking about some causes of error in the lab, at that point we would look at our value, and if we would have a negative percent, this is probably a chance that maybe we lost some of our mass, or in this case, maybe the cube that in the corner could have been slightly dented, so we didn't get a full 3 centimeters here. And maybe that affected the other side of the cube whenever we mismeasured. So there is some meaning to our percent values that we get. And as we go and perform our labs, we'll look at our percent errors and then we'll talk about what could have caused them and how to improve upon them. So if you could go on and finish the next 3 practice problems, make sure that you show your work, you label your answer with your percent sign, and you circle it. And after you finish, go on and submit.